Hello, AP Chemistry students. This is Mrs. Altman. We are on video number 37, Solubility Equilibria Part 1. This is chapter 16 of your textbook. Here are our objectives for today's video. Pause here. So last year when we were talking about solubility, we talked about things that were soluble and things that were not soluble. And I probably even told you at the time that you would see in about a year's time that I was not exactly lying, but misrepresenting things a little bit. And in this chapter, we're going to talk about things that we would typically consider to be not soluble, but we're going to see that pretty much everything is soluble to some extent, just to very small extents. So, for example, calcium hydroxide, it doesn't dissolve in water very well. It's considered to be insoluble, but it will, to some extent, form a aqueous solution. That's why I'm using equilibrium arrows. And the solid state will be in equilibrium with the aqueous state. Because it's always going to be solids on the left with the dissociation reaction, we're going to call, instead of the SP there stands for solubility product. It's always going to be a product since we're never going to have a denominator, and S for solubility. Otherwise, all equilibrium rules still apply here. Pause here. Right, I'll work through it. I'm going to write out the dissociation reactions really just to practice. You don't really have to per se, but if you haven't done it in a while, it wouldn't be a bad idea too. Pause here. So the solubility product is related to how soluble something is. Typically, the higher the KSP value, the more soluble something is. You can only really use it as a basis of comparison if between two different salts, though, if their equations look the same, meaning they're both producing one positive cation, one anion. If you start getting different coefficients, then you have to do some other things before comparing solubility, which we'll talk a little bit about. Pause here. Right. So when I say that the solubility of something is that, what that means is that the concentration of silver chromate is going to be equal to 0.00013 molar. What that really means, though, is that Ag concentration is actually double that. And I should have put a plus there. And that CrO42 minus is equal to that. If you don't immediately recognize it, I would suggest that you write out the dissociation reaction for that. All right, I'm going to have to turn this into 2 videos, so I'm going to pause here for a little bit, and then I will continue the rest on another video.